Now, let's look at question here. The letters x and y represent rectangular coordinates. Write the equation using polar coordinates r theta. Previously, we are given polar coordinates. We want to convert the corresponding equation to the rectangular coordinates. Now we are given rectangular coordinates equation. We want to convert that to the polar coordinates. Now, we are given the equation, and we need to use again those three identities. X is our cosine theta. We replace this x. Then since x is squared, then we have a r squared cosine theta squared. When you square x, you want to square both r and cosine theta. And the y is r sine theta. So you just need to replace this y with r sine theta. Since both sides have a r, you divide r on both sides. You have a r times cosine theta squared equals 4. This r cancelled. That will be sine theta squared. So this will be the polar equation corresponding to x squared equals 4y squared. That would be the one right here. Now, if we are given this equation in polar form, then it's hard for us to actually think, how does the graph look like? But from the rectangular equation, we can see this is just a parabola. You see both sides divided by 4, where one stands alone on one side, and the other side is 1 over 4 times x squared. That's the standard form of a parabola with the open direction upward. Because again, x is squared is positive. Positive times positive number 1/4, you get positive. So y can only choose positive values. X can be positive, negative. So the open direction for this one is upward. Again, in decimal, you can input this equation, x squared equals 4y, or y equals 1 over 4 times x squared. You can also input your equation in this way. That would be this. R cosine theta squared equals 4 times sine theta. You also get the same picture. Here, the advantage and disadvantage for the polar coordinates is that sometimes you are given a polar equation, you do not know really how the picture looks like. But sometimes, as we have seen previously, to represent a circle is quite easy. So it depends on really what kind of picture it looks like. Sometimes it's very simple form. Sometimes you are given this form, you cannot really find out how does the picture look like. You have to convert that to the rectangular coordinate equation, and that's easy to see. So really here it depends on the situations. We need to study both, and we want to choose the convenient or simple equation. That's the purpose to learn the polar coordinates. And that's the reason to learn the relationship between the polar equation and rectangular equation. All right, I'll see you next time.